Chris Morris here, taking you through this idea of normalisation. As we've discussed, one of the main issues with a flat file database, while it's quite simple and effective for most small applications, there is a problem insofar as that it can create data redundancy. You may remember the definition of data redundancy is the unnecessary duplication of data within a database. And so when you start to create relational databases and the amount of data that is stored is substantial, then there is a chance that some data can become redundant, and that's not what you want within a relational database. You want to make it as streamlined and as efficient as possible in relation to its storage and therefore accessing it later on. So just taking you through this understanding of normalisation, and as I said, it's the removal or attempt to eradicate data redundancy within a relational database. So if we look at the first example here, we can see that there is a simple database where student ID is a unique identifier for each particular student, and you can see the surname is there, and each student belongs to a particular subject which has a course ID, a teacher, a room, and an assessment mark attributed to that particular course. Now you can see the way it's set up at the moment, that each student has a number of different subjects, but they're all listed under the one surname. So in terms of it being an efficient and effective database, we'd say in this case that it wouldn't be, and it's more than likely going to be a Word table or an Excel spreadsheet, and which sort of limits you in a lot of ways in relation to what you can do with a database. So we're going to use this as our stimulus for the discussion of normalisation. And if I scroll down, you can see that quite clearly that the ID number is unique to each student, and straight away in our heads we should be thinking, well, if it's a unique attribute, then it can become a primary key to identify that student. So what we need to do is we need to change this structure and normalise it, and the first step of normalisation is what we call first normal form. Now you can see here that in creating first normal form, we have Willette now has been attributed the ID 870124, that's her student ID, and she does IPT in English and Maths, and you can see that they are unique tuples or records within the database, which is really the way it should be. It's not going to work as was the case up here in terms of effective sorting and querying the database. So you can see now that each particular entry has been given a unique status, and it's a record or a tuple within the table. Can you see one of the problems? Let's look at ID, for instance. If we made ID a primary key, what is one of the main rules associated with a primary key? You can get some thinking music. No, you can't. Okay, you should have thought about the idea that a primary key must be unique. And here you can see that 870124 actually repeats 4 times. 860210 repeats 4 times, as does 870069. So not only do we have redundant data, but we have something that would not work in a relational database, because if it was attributed to be a primary key, then as you know, when you try and add data to a primary key, that is duplication, it doesn't allow you to do so. So what we need to do now is address these three issues. The primary key is no longer unique. If a subject name is changed, then every entry containing the subject needs to be located and changed. So we've got problems associated with that here. The information about a teacher is still lost if all the subject records for one subject are deleted. So we've just broken it down to first normal form. We've given each particular entry an attribute. What can we do now? We need to go into second normal form. Now, with second normal form, it involves establishing a new relation for each dependent group, and this involves dividing things into structures. Now, ultimately here we have simply a flat file table. It's a two-dimensional table. Okay, we need to actually change that now because you can see there is unnecessary duplication. Okay, the best way to do that is to think, okay, what sort of groupings are there here? Alright, so you've got, details about the student. Okay, I don't really know much more other than the surname of the student, so we need to address that. So we've got details about the student. We've got details about the subject, such as, the course, the subject, and who teaches the subject, and what room it's in. And then we have things about the assessment, so how students went in that particular subject. So there's sort of three distinct groups, and you can see that here we've got students, subjects, and marks. Okay, students have an ID. The ID is dependent on surname and subject. Course ID has dependents called subject, teacher, and room, and assessment mark has a dependent called subject and surname. Okay, so with second normal form, as with any hierarchy, 1, 2, and 3, we haven't fixed all of the problems. There will be still some repetition. Okay, students, subjects, and marks. So what we need to do is then go to the next step, which is third normal form. Now, third normal form removes attributes from some entities and sets up a new entity called teachers, with the attributes teacher and room. So you can see now from essentially the flat file structure that we have here, we now have normalized the data. We've got rid of the data redundancy, which you can see here is IPT, geography, English is redundant, course ID is repeated a number of times, as is teacher, as are rooms. Assessment marks are unique anyway, but you can see there's inherent redundancy there. When we move via first and second and third normal forms, you can see that we're starting to eliminate the data redundancy. So with these normalized tables, we now have a table called students, which has a primary key student ID, surname, and the subject codes that they are enrolled in. The subjects table or subjects entity now has a unique ID, and each particular subject is given a unique ID. The marks table has student IDs, course ID for which they are studying, and an assessment mark, and the teachers table have the teachers' names, the room that the actual course is in, and the course ID. Now from this point, you could actually construct an entity relationship diagram. Entity relationship diagrams, also called schemas, as you know, provide almost like a map of how the database fields link together, and you can see how the different database fields could link together in this particular structure. So one of the things I'd like you to do is to construct an entity relationship diagram, also representing the types of relationship which occur between the different entities. Remember, the three types of relationships are one-to-one, one-to-many, and many-to-many. I'd also like you to complete the associated questions 1 to 12 here. Okay, hope you have a better understanding now of normalization, and any questions I'll cover in class.